Alright everybody, I've been getting a whole bunch of questions about, well, how do I hook up relays? Where do I put fuses? How big should the fuse be? What does my light ring on my speaker use? What does all this stuff actually mean? How do I pick the right relay? Well, let's go over some of these things. Here I got a battery, a switch, what the bottom of one of those little automotive ice cube size relays will look like, little 1 inch by 1 inch by 1 inch cube, and then LED. If you're not familiar with this symbol, that's a diode and it's light emitting. That's negative, that's positive. So, how do we set this thing up and we put it on the boat? Well, first off, here's your battery, and we're going to use the battery to power this. So, in order to do that, we need to make sure that we have everything set up the right way. Now, first off, to get this relay actuating, there is 3 different things. One, to recognize which one's the solenoid, which is the part that's going to be kicking it on and off, which side's the input and which side's the output. In this case, on this particular relay, these numbers, they may not be perfectly correct. These might be switched and these might be switched, but that's okay. When this relay is not hooked up to any power, it's just sitting on a table, the number 30 pin and the number 87 pin are connected. So if I hook power to this, power is going to come out in the middle. If I hook power to the middle, it's going to come out of the 30. So what I want to do is I want to power this relay. This 87 in this case, the middle pin, is not going to be connected because I want this to be off until I turn the switch on. So first off, we have to recognize when 85 and 86 get powered up by this switch, or one side gets powered up and the other side's ground, this relay will switch from here to here to being from here to here. So this is your input, and then you pick which one of the outputs you want to use. So in this case, we'll have positive running out to the switch, and I'll draw that one in a second here. And we'll have negative running out to either side. It does not matter, it's the same thing. It's a coil. It's not polarity sensitive. Now, why did I not connect the positives? Because we're not there yet. We don't know how much power that diode is going to draw. So we'll leave that blank for right now. But in theory, this is going to run out here to this side, and it's going to run to this one. And actually, I wrote that wrong. So those two are going to be connected now. So what we want to do is we want to take a go hard look at this. When we push this switch down, this pin will energize from this one. So these two will be connected. When the switch is open, these two are connected. So when we go to hook up our LEDs, what's going to happen is we're going to have the positive coming out, and it's going to run to the 30. And then this one here is going to come out, and it's going to run to the LED on the positive side. Then we're going to connect the negative directly to the LEDs. That's all the wiring. Wiring, not fuses. So now we come into the issue of, okay, so how much power is this thing drawing? Well, as of right now, the way we got it set up, negative runs to 85, negative runs to negative of the LED. Positive runs to the switch, which runs to 86, and then runs to 30, which when we push the switch will energize 87A and turn on the LED. So now that we get the wiring routing figured out, what do we do for protection? Well, first off, let's put it this way. Protection on positive wires goes directly next to the battery. You don't put it next to the LED, you don't put it right before the relay, you put it at the battery. Why? Because we don't care if this stuff fails. It's not there to protect that. this over here stops all this wiring from turning into a toaster oven. So you want to make sure that you have a fuse. So when we come out here and we want to fuse this, the switch going to these relays is like roughly, I don't know, we'll say a half an amp is a pretty sufficient size fuse. So we're going to put a fuse right here, 0.5 amps. And that's going to be a fast blow fuse. That's not going to be a slow blow fuse. We want to make sure it kicks off the moment something goes wrong, not slow. Now what do we do for the LEDs is the next question. Well, that comes down to very simple math. V equals IR. Is voltage, current, resistance. We can measure on both sides of the LED a resistance. Now if you put on the negative side the positive probe, you're not going to get anything because it is a diode. Diodes are like check valves. It can only flow this direction. So you have to put positive on the positive side, negative on the negative side, and get the resistance of that system. If it's a speaker ring, same deal. Positive to positive, negative, negative on ohms. And you're going to read that off. Let's say it's 1 ohm. So we got 1 ohm. That's the symbol for ohms. That's what we get at the LED. Now, next question is, we have to have 2 of these to actually solve the equation. So we have 1 ohm. What is I? We don't know because that's what we're trying to figure out. So I is not solved. What's voltage? That's this guy right here. Now if current goes up and voltage goes down, that means more heat. If voltage is dropping, you're going to have more current. So we're going to take it on the low end of the battery. Since we're talking about boats here, we're going to say 11.5 volts. Now why did I pick 11.5? That is because that is about the maximum draw you're going to get before other things like GPS and amplifiers and radios start shutting off. So we want to pick the one that's going to cause the most current. Now we just solve. So if your LED or ring, or let's say all of these are all tied together and you just checked it for the main wire coming back from 10 of them, all comes back as 1 ohm combined, all we got to do is sit there and divide voltage by resistance. So we're going to divide both sides by 1. You know what we're going to get? 11.5 equals I. So 11.5 amps to power this LED. Is it going to be that high when you test it? Probably not. This is probably going to come back as like 2, 3, 4, 5, or 600 ohms. And this is going to be somewhere in like a quarter of an amp range, like 0.25. But for the sake of this testing here, we're going to say 11.5 amps. Now, for safety reasons, we're going to say 11.5 times 20%, or 1.2. Why are we doing that? Because if we add 20% to it, then a low voltage, let's say it gets down to like 11 volts, we have a little bit of a buffer. We don't want the fuse to be the exact amount, otherwise the fuse is going to blow when you turn them on. So we add 20% to it. So when we do that, we're going to say, what does that come out to? Let's calculate that out. 1.2 times 11.5, that gives you 13.8. So you got 13.8. Now you need to either find a 15 amp fuse or a 10 amp. Well, 10 amps not good enough for this, so throw a 15 in there. A 15 is still good to stop if this shorts out and fails. And that fuse, where that one will go, is right up here. You're going to put it right next to the battery. And that's it. You have a fuse to protect the relay and the wiring ahead of it and the switch. And you have a 15 amp relay to protect all the wiring for the LEDs. If one of these shorts out, that 15 amp will blow. Some might say that, well, what if the wire can't handle 15 amps? Well, that's okay, because at this point the LEDs are on. It can deliver as much power as the LEDs are drawing without causing a problem. If this wire gets hot, that means it's drawing substantially more than what the original 13.8 or whatever amps, 11.5, was pulling before. If you can do that all day and all season, believe me, 15 amps is going to be a pretty huge spike as far as the fuse is concerned. But there you have it. That's how you wire up these switches. So technically, your battery negative is your source, and then your 87A or bottom pin is going to be the one that is your positive. So when you're hooking up your LEDs, don't hook them to a power source over here. Just get your battery, your switch, and your relay ready. Run a ground off the battery, run a positive off the 87A. And that's it. That's how you calculate it. That's how you get that. Now if you go around and you're checking all these LEDs and you got like a light ring here, a light ring here, and a light ring here, and let's say all the positives are coming off the same side, and then all the negatives are coming off the same side, that is okay, as long as you know what is the ohm load between these two. Okay? Now if you have a light ring, a light ring, and a light ring, and this positive's going here, this negative's going here, and this negative's coming off, and this one's coming off, and they're just wire to wire to wire to wire to wire, and none of them are side by side, you're still going to have the same thing. Check both sides. Remember, if you're getting no resistance, it is because you're checking the wrong side. So check both if you're unsure. Whatever the positive wire is to power them is the positive for the multimeter. If you got any other questions, place them down in the comments below. Like and subscribe, and that's it, guys. Good luck.